Hi, my name is Siavash Samadian Barzoki, and this is the course project for the Managing Machine Learning project as part of the AI Product Management specialization of Duke University. So we are supposed to have a project for machine learning solution and go through the process and see um, how it works with that. And then what I selected was the fraud detection system. And why there's a problem there? The reason is that there's an increasing fraudulent bank transactions. And for example, in 2023, there were $10 billion of the fraudulent transactions. And the existing machine learning, the existing rule-based system cannot address that because the fraudulent activities are in the rise. They're more complex, and cannot keep up with that. So, but machine learning can work with a large transactional data set, historical data set, and analyze them and identify the complex patterns in them. So, you can solve that. So obviously, the customers care about that. They don't want to have their money be lost and the fraud impacts them. The banks care because they don't want to have the financial losses. They don't want to. They want to enhance the security and they don't want to be impacted by the reputation damages. And they need to have the trust of the customers. Regulators also care because they want to make sure that it is compliance. The activities of the bank is compliant and they have their oversight on this. So there is the problem there. Technically, it is possible. The machine learning can detect the patterns and trends and anomalies of large data sets. They can have the labeled data, so they can use the supervised model because they already have the historical data that which transaction was programmed, which was not, based on the previous rule base that they had. And also, at the same time, they can use unsupervised learning systems like anomaly detections and clustering and those kind of things. That so is also possible to use. That there are some challenges that we are going to address those, like the the need to look at the briefs and those kind of things that we come to them later on. So the data is also available because, as I said, the banks already collect a vast amount of the transaction data, including the timestamps, amounts, locations, channels that the customer do the transactions and those kind of things. There are like the information of the device that they are using to do the transactions, spending habits, and customer profiles. Also, there are the information that's shared by the regulators and the different consortiums are available there. So there are a lot of data sets available for that. Those data sets are also accessible because the transaction data is obviously coming to the bank for the authorization and settlement. So those information is there. There are some privacy considerations, so compliance with the specific rules like GDPR or CCPA and those kind of things that they need to consider. But other than that, the data is available and accessible. And also, there are some implementation requirements. Obviously, we need to have the robust data pipeline and real-time processing of transactions. And as I said, the considerations of the data privacy and security should be there. And also the continuous improvement of the system because of the changes in the system that of different types of frauds and like consumer behavior. So there are some implementation requirements, but it's possible for us to do so. The problem that we are defining here is that there are fraudulent transactions happening in the banking systems, and which can have the financial and reputational damage. So the goal of this ML system is to detect the fraud in the real time and improve the accuracy and reducing the false positives. Why? Because we don't want to flag a transaction and prevent it as a fraudulent, but actually it was not a fraud. So we want to reduce the false positives also. And the target users for this system for us is the banks, fraud detection teams, and IT departments. And why it matters, as I said before, there are billions of dollars of fraud existing. Currently, it is getting more sophisticated, and the consumers are getting more dissatisfied with the financial losses are affecting the whole banking system. And also the current state is that the systems that are available are rule-based systems to flag. They are prone to errors. They are inefficient, so they are not matching with the demand. And so obviously there is a gap there between the current state and what is needed. And we need to be more adaptable to evolving fraud tactics and we need to reduce the high false positive rates and then slow response time for the fraud. So there are gaps to address. And what we expect as a business impact is that the financial losses due to fraud to be reduced. Another outcome can be to improve the customer trust and satisfaction by reducing the false alarms. And so that can be another outcome. And also another outcome can be the operational efficiency for fraud detection teams should be enhanced. So that's another one. The metrics that we can have, for example, for outcome metrics, we can consider, we can define a percentage of the reduction in the fraudulent transactions that that are there. And another thing that we can define is that we define another percentage for number of the customer complaints related to fraud. So that's also another outcome metric that we can define. Output metrics from the system and model is can be precision, recall, and F1 scores for the fraud detection, and as I said, the number of the false positives. Also, that's also can be one of them. The recall should be as high as possible. So those are the output metrics that we can have. Some of the potential factors that we can consider are the transaction characteristics like amount, time, location, and frequency of those transactions, the user behavior like spending patterns and device information of the users, some external data like IP addresses, geolocation data, or flag fraudulent accounts that are available there, some historical data like previously identified fraudulent and non-fraudulent transactions can be considered the identified factors that can be used as a features for our model. So next is that how we are going to address these is that first we can create a mock-up interface and show some flagged transactions and gather some user feedback how they can feedback and respond to that, and then we use that mock-up with that first one was to understand the business understanding, and then we go and have using that mock-up with a small subset of the historical data to understand data. And after that, we can use the real historical data plus some simple heuristic or rule-based data that algorithm that we have, or use just a simple machine learning algorithms for them on the mockup. The next step, we can enhance it and we can do some prototype models with a better algorithm on historical data and evaluate the precision and recall and improve on that, simulate the real-time predictions with anonymized data, and refine the thresholds of that we have on the fraudulent alarming. And then the next is to do some pilot deployment for real-world testing, and we can have a subset of the users in a subset of the locations that we have in the national locations or national if the bank is international, and when that was good result, then we can expand it to the whole nationwide and to all our user population. And also, we should have some monitoring framework to look for the data drifts and concept drifts with using the statistical testing and monitor the latency and output of the performance over the time to make sure that we during the validation monitoring we monitor the whole thing. And then we should have the retraining strategies to make sure that on a schedule times we retrain the whole thing based on the aggregated data and or retrain on when we see a specific like big performance decline in our model. So there are some design considerations like should it be uh, cloud-based or not? So that's also one thing that we consider. And